Okay guys, welcome back to the video. In the previous video, I introduced you trichotomy law, right? Which satisfy these three properties, okay? And we know that the only subset of set of integer that satisfy trichotomy law is a set of natural number. And we already proved it in the previous video. Today we are going to prove this theorem, which is the zero property and which is the zero product property and the cancellation property for multiplication. So let's go to the proof of this property, zero product property. So let a and b be two integers. If the product of these two integers is 0, then a equal to 0 or b equal to 0. Now, how do we prove it? If the conclusion has statements connected by or, I want to use contrapositive of conditional statement. For example, a contrapositive of this statement, if P then Q, where P and Q are two statements, okay, is going to be not, if not Q, then not P. Meaning, if P then Q is equivalent to if not Q, then not P. Okay? We will use this one to prove this theorem. So now, let's prove it. So we will use a proof by contrapositive. Okay? So I will let a and b be two integers. And what is the contrapositive of this statement? The contrapositive is going to be not this statement. Not this statement is a is not 0 and right b is not 0. Then not this statement. Then we're gonna have a times b not equal to 0. I think this way is easier than proving this one directly. So I'm gonna assume that this statement is true, meaning a is not 0 and b is not 0. Okay? And try to show that a times b is not 0. Okay, so what can we do next? How can we go? We will use trichotomy law right here. We will use trichotomy law because why? Because a and b are integer. Okay. So once a and b are integer, which trichotomy law that is satisfy? The last one, right? Okay. So if x is an integer, x can be positive integer. It can be 0, or it can be negative integer. So let's use trichotomy law by trichotomy law, the third one. Okay. So AB is an integer and they are not 0. right? They are not 0. Okay, so it implies that a is natural number, or minus a is natural number, meaning that means that a is a negative number and b is a positive integer, or b is a negative integer. Okay, wait, what can we do next? What can we do next is to use trichotomy law again, the second one, and use the product rule here. Okay, so if you pick two natural number, the product of that natural number is still be a natural number. Again, by trichotomy law. And I will split into 4 cases. Okay, a is a positive integer, b is a positive integer, a is a positive integer, and b is a negative integer, and a positive a negative integer, b positive integer, and both a and b are negative integer. Okay, so by trichotomy law, the second one, what do we have? Okay, the first case is both a and b are positive integer. Trichotomy law implies that a times b is natural number. Okay. Another case is that a is positive, but b is a negative integer. So what do we have here? We're gonna have a times minus b, which is minus, right? Okay, let me write like this. Minus ab equal to a times minus b. And a times minus b must be a positive integer. Another one, minus a being a positive integer, and b is a positive integer. Now what happened in this case? For this case, we're gonna have minus ab equal to minus a times b, which is a positive integer. And the last case, minus a is a positive integer, and minus b is a positive integer. Okay, for this case, if a and b are negative integer, we're gonna have ab equal minus a times minus b. And by trichotomy law, the product of two positive integers is a positive integer. And what do we have in this case? Okay, hence we're gonna have a b being a positive, ab being a positive integer, okay, or minus ab being a positive integer from these cases here, from a being positive, minus a being negative, and b being positive, and minus b being negative. So what does it imply here? Okay, so if ab is a positive integer and minus ab is a positive integer, for this right here, it implies that ab is positive. It cannot be 0. Okay, and in this case right here, ab is negative and a times b is an integer. This means that a times b cannot be 0. Okay, so from this right here, this implies that a times b cannot be 0. So we prove this theorem by using a contrapositive already. Okay, next one. Let's go to this corollary. This is cancellation property of multiplication. If I let A, B, and C be integers, and if I have this equation A times B equal A times C, and A is not 0, then B equal to C. Okay, what can we do with this? Let's prove this theorem or this property. This is cancellation. Okay, cancellation for multiplication. So I will let A, B, and C be integer. Okay, and assume that A times B equal to A times C, and A is not 0. Okay, and A is not 0. If I have AB equal to AC, I want to have B equal to C. Okay, what can we do with this? Okay, so let me start with this. So we're gonna have A times B minus C equal A, B minus AC, right? What happened to this? AB equal to AC. So when you have two equal number and subtract each other, then it turns out to be 0. You might write AC minus AC like this, and it turns out to be 0. What does it mean by this? Now you have A times B minus C equals 0, right? Okay, A times BZ right now is 0, but A cannot be 0. Once A cannot be 0, the only one that can be 0 is B minus C. Hence, B minus C is 0. Once B minus Z is 0, what do we have? If you have the difference of two number that is 0, those two numbers are the same, right? So B is C. That's it. This is cancellation property. Okay? So if you have AB equal to AC and A is not 0, and A, B, C are integers, this implies that B equal to C. Okay? So that's it for today, and see you in the next video.